In this lesson, you're going to learn how to solve equations that contain fractions, or in other words, rational expressions. So, to solve equations, what you do to one side, you do to the other side. So I'm going to show you the difference between solving an equation and simplifying an expression. So on the left here, we have an equation. How do we know it's an equation? Because there's an equal sign. As long as there's an equal sign in the original problem, you can multiply one side by something, and that would also mean you would have to multiply the other side by the same thing to balance that equation. So that's the reason why you may see a scale when we talk about solving equations. So if you see this scale over here, all they're saying is whatever you do to one side, you do to the other to balance it out. Now, for the first equation we have rational expressions or fractions, and what we normally do is get rid of the fractions first. How do we get rid of the fractions? We multiply by the LCD. We look at the denominators. We have 3, 4, and 6. What is a number that we can divide 3, 4, and 6 into? So we divide 3, 4, and 6 into what number? Well, the easiest way to do that is to look at the largest number, 6, and think about the multiples of 6. For example, 6. Can 3 and 4 divide into 6 evenly? No. What is the next multiple of 6? 12. Can 3 and 4 divide into 12? Then that's when you know you have found your LCD. Let's multiply by 12. And notice we're going to multiply both sides by 12, or else the equation is not balanced. So if we multiply the left side by 12, notice we have a plus sign here, so that means we have two terms. We have two fractions here, so we're going to have to multiply 12 by both fractions. So we're distributing. So let's write it out. What are we multiplying 12 by first? We're multiplying 12 by x minus 2 over 3. But we also have to multiply 12 by x plus 1 over 4. And of course, 12 is going to be multiplied by 1 over 6. Here's where we start canceling out things, because if 12 is considered to be 12 over 1, right? If that's 12 over 1, then our 12 obviously is in the numerator. But this 3 is in the denominator, for example. So that means 12 divided by 3, right? And 12 divided by 3 is reducible, right? So that's why we divide 3 into 12. We get 4. And of course, 3 divides into itself one time, but there's no need to write that. So what's remaining is 4 times x minus 2 for that part. And then we move to the next. 4 goes into 12 3 times, so that's 3 times x plus 1. So see how we are getting rid of the fractions here. And then next, on the right side, 6 goes into 12 2 times. And all of this is just 2 when you look at it. It's just 2 remaining. And then what we can do is solve for x now. But we're going to have to distribute again, right? So 4x minus 8 plus 3x plus 3 equals 2. What are we doing next? Like terms. So that's 7x minus 5 equals 2. Then what we're going to do is add 5 to both sides. That cancels. 7x equals 7. And then we're going to divide both sides by 7. 7 divided by 7 is 1. So that cancels out, as we say. X equals 1 is the final answer. Now, On the right side over here, we are simplifying expressions. So simplifying, so two different functions here. We're simplifying on the right, but on the left, we were solving. We solve equations and we simplify expressions. Well, this looks very similar to what we just did, but notice there is no equal sign. So our whole objective is totally different. Our objective here is to combine two fractions as one. And how do we start? We start with the same thing. We start with the LCD. Our LCD is 12. So what we do with that is that we multiply the denominator by what would give us 12. So we're going to multiply 4 on the left side and 3 on the right side. Then we can combine these two fractions as one. So that's 4x minus 8 when we distribute plus 3x plus 3, which is 7x minus 5 over 12. So notice our answers are totally different despite the fact that our problems look very similar. So notice for simplifying expressions, we receive an answer of 7x minus 5 over 12 versus on the other side, we receive an answer of x equals 1. So when you're solving equations, your variable is going to be on the left or the right. It doesn't matter. Your variable is going to be on one side, and normally is a number on the other side. Let's move on. So in your own words, what is the difference between solving a fractional equation and simplifying expressions? Well, in one case, we are solving for the variable. So when we get to the end, we're going to have the variable on one side and the number on the other side. But with simplifying expressions, we are combining two fractions as one. Now here we are solving again. So we determine what the LCD is. And notice here we have n and we have 2. So our LCD is 2n. 2 times n is 2n. So we're going to multiply both sides by 2n. So that means 2n times 5 over n. It's best to write it all out if you can't calculate it in your head, right? So write it all out like what I'm doing here. And then 2n times 9 over n. Then we start canceling things out. So the n's cancel here, and we're left with 2 times 5, which is 10, plus the 2's cancel. We have n times 1, which is n. The n's cancel here. This is a 9, so 2 times 9 is 18. And then we're going to subtract 10 from both sides, and we have n equals 8. Now, what we have to be careful about with problems like number 2 is that we have a variable in the denominator. When we have a variable in the denominator, we have to check to make sure that when we plug in 8 into that variable, we don't get undefined. We get undefined when our denominator is 0. Now on the right side, I said simplify, and I want you to simplify 5 over n plus 1/2. That's it. Are you able to do it? So if you started with the LCD, then you started right. The LCD is 2n. So we need to multiply this side by 2 and the right side by n so that we have a denominator of 2n. So we combine this now because our denominators are alike. 2 times 5 is 10, plus 1 times n is n, and we are done with this simplification. Now again, let's recap. We must be careful when our denominators contain variables with equations. Now when we're solving equations for this one. If this happens, we consider what solution when substituting into the variable, n in this case will make the entire denominator 0. This one was easy. What n value will cause the denominator to equal 0? Because this entire denominator is n, then it would just be 0 for this case. If n was 0, that would be a problem. Therefore, for the problem above, the restriction is the following. N cannot equal 0 for number 2. And we did get 0. We got n equals 8, so we are okay. Let's move on to number 3. Do we have a variable in the denominator? No. So we don't have to worry about restrictions. So we're solving an equation, and what do? We multiply by the LCD. So try to figure out what the LCD is before I reveal the LCD. So in this case, it would be 10. So we're going to multiply the left side by 10 and the entire right side by 10. If you wanted to turn, so not only are we multiplying 10 by x over 2, we're also multiplying 10 by 9. So here we have 5 divided into 10 2 times, so that's 2x equals 2 goes into 10 5 times, so that's 5x minus 90. Now we are simply getting our variables on one side, and then we're solving for x. Now you could do a few things here. You could simply subtract 5x from both sides, and you'll get negative 3x equals negative 90. You could have added 90 and subtracted 2x. So whatever your preference was for that. Now we're going to divide by negative 3. And x would equal 30. Now, I said, what does it mean? It's saying that if we substituted 30 for x in our original problem, and our original problem is here, x over 5 equals x over 2 minus 9. It's saying if we made that substitution, we're saying that 30 will satisfy the equation. So 30 divided by 5. 5 goes into 30 6 times equals 2 goes into 30 15 minus 9. So it does satisfy this equation because the left side equals the right side. So 30 would be the only number that would solve this equation. Notice I labeled it as level 2. Now what are our restrictions? The best way to look for restrictions is simply go to your denominator and you will set your denominator or denominators to 0 and solve for x. So here we have x plus 3 and x plus 2. What you're going to do is set x plus 3 to 0 and solve for x. And you're going to set x plus 2 equals 0 and solve for x. So you have subtract 3 here. Our restrictions are x equals negative 3. And we can't have a negative 3 here. And also negative 2. We do not want our final answers to be negative 3 or negative 2. Why? Because those are the numbers that will make our denominator 0. How do we know that? Because we just set it to 0 to figure out what x will make it equal 0, and we found it to be negative 3 and negative 2. Now let's solve the equation. What are we doing? We are multiplying both sides by the LCD, and the LCD is x plus 3 times x plus 2. So we multiply both sides by x plus 3 times x plus 2. Now that seems really complicated, but once you write it out and start canceling things, it's a little simpler than what you expect. It's a lot of writing though, as you can see. Now on the left side, first thing we can cancel is x plus 3 and x plus 3, leaving us with that x plus 2 times x. I mean, you can just go ahead and multiply it if you want to, But of course, I have to write it out. I'm the teacher. And then in the middle, x plus 2 times x plus 2. And then you have x plus 3 times 1. So we just write down x plus 3. And then over here, of course, 1 is also, again, obsolete. If you wanted to, you can go ahead and multiply that out. But I'll get it done on the next line. Then we have x squared plus 2x plus x plus 3 equals, and now we got a 4. So now we have x squared plus 3x plus 3 equals x squared plus 5x plus 6. Now what we want to do is get like terms together. But notice if we subtract x squared from both sides, which we probably should tackle first, if you can get rid of those x squareds, that would be amazing. So, and we were able to get rid of it. So 3x plus 3 equals 5x plus 6. And then you're going to get your like terms together by, you can subtract 5x if you wanted to. Alright, that's one option. That's not the only option. So that's negative 2x plus 3 equals 6 now. And then you can subtract 3 from both sides. Then that would be negative 2x equals 3. And then you can divide both sides by negative 2. X equals negative 3 halves is your answer. Now, is that answer okay? Is x equals negative 3 halves okay? It's perfectly fine because our restrictions were negative 3 or negative 2. So if we had, if our answer ended up being x equals negative 3, then we would have to say no solution for this problem. Because if we plug negative 3 back into this x here, then we'll get negative 3 plus 3, which is 0. Or if our answer ended up being negative 2, we will also have to say no solution because of this x here, because negative 2 plus 2 is 0. But we didn't get that. We ended up getting the answer of negative 3 halves, which is perfectly fine. The minus sign, so you're going to have to be very careful about this problem. What is the LCD? It is x minus 4 times 2x minus 1. So that's what we're going to multiply everything by. Now, we're going to do that times this. And again, if you are new to this, you need to write everything out like so. Now, what we didn't discuss is the restrictions. So what are the restrictions to this problem? Now, again, let me go over it one more time. You gotta catch it. To find the restrictions, do what? You need to set the denominators to 0. Remember, and solve for x. So a restriction is 4. And what's the other denominator? 2x minus 1 equals 0. You're going to add 1. And then you're going to divide by 2. So the other restriction is 1/2. Now, if your answer ended up being 4 or 1/2, what would you conclude? You would conclude that there's no solution to this problem. We have x minus 4 is canceling out here. And we have that x left over and that 2x minus 1 left over. And then we have 2x minus 1's 4 times x minus 4 left over equals, and then we have that 1 times x minus 4 times 2x minus 1. Again, that 1 is pretty obsolete. You don't even have to write that. Alright, so now we distribute. We have 2x squared minus x minus 4x plus 16. Why? Somebody's going to say, why plus? Okay, well, there's a negative times a negative there, which is positive. And then we're going to FOIL, because this is a binomial times a binomial. And so let's just get our like terms together on both sides. So on the left side, we're going to have 2x squared minus 5x plus 16. And on the right side, we're going to have 2x squared minus 9x plus 4. I like the fact that we have 2x squared on both sides, because when we subtract 2x squared from both sides, we get rid of those x squared terms, which is awesome if you can get rid of them. You're not always going to be able to get rid of them, which will lead you to 4 extra steps. All right, so then we have negative 5x plus 16 left over equals negative 9x plus 4. Let's add 9x to both sides. Then you will have 4x plus 16 equals 4. And then let's subtract 16 from both sides. So you will have 4x equals a negative 12. And then you divide by 4, right? X equals negative 3 is your solution for that one. All right, next. So we can conclude that negative 3 is our solution to that problem because it was not 4 or 1/2, okay? If it was 4 or 1/2, you know what to do. There will be no solution. Let's move on to this problem. We have a proportion here. So what you could do when there's a fraction equals a fraction, if there's a fraction, one fraction equals one fraction, you could simply multiply those two together. All right, so if y'all ever done, I call that the butterfly method. If you want to just multiply like that, and then it would be 4 times 5x plus 2 equals 11 times x minus 6. It will work perfectly fine because these are proportions. And proportions look like this on the right. If it's a fraction, one fraction equals one fraction, you can do that little butterfly method. But again, this is solving an equation with rational expressions. You can simply figure out what the LCD is, which is 4 times x minus 6. And you multiply both sides by 4 times x minus 6. What are your restrictions? Can you tell me what your restriction is for this particular problem? And there is only one, you guys, because the variable is showing up over here, as you can see. There's no variable in this one over here. 4 is going to remain 4 no matter what. You can't make it something else. All right, so your restriction, if you said 6, then you know what you're doing. All you had to do was set x minus 6 to 0 and solve for x. So we don't want our solution to end up being, well, it's really not our solution, it's an extraneous solution. What is an extraneous solution? It's sort of like a fake solution, or I like to say is an extra. That's why you see extra in extraneous solution that actually doesn't work. So it's really not a solution, even though we say extraneous solution. So if we got an answer of 6, then we know that we conclude that there is no solution that works for this problem. All right, let's start canceling. Our x minus 6 is canceled. We have a 4 left over and a 5x plus 2 on the left side. And on the right side, our 4 is canceled. We're left with that 11 times x minus 6. And then we distribute, of course. Then we subtract 11x to get our 9x plus 8 equals negative 66. What do we do now? We subtract 8 from both sides. And then we divide by 9 to get an x equals negative 74 over 9. Interesting. All right, I don't think we can reduce that in any way. And it's not 6, obviously. So we move on to the next problem. 2x plus 1 times 2x minus 1 times x minus 2. So sometimes you're going to have an LCD that has 3 different factors, which is a lot. All right. So So again, you're going to distribute that, and that's what I want you to do for the next step. I want you to distribute. I want you to write it all out. I'm going to start writing it all out, okay? I want you to write it all out and make sure you know what you're doing. And I also want you to write down what the restrictions are. So go ahead and pause the video. Write down the next step and write down the restrictions. Okay, so if you wrote down that we can't have, we don't want a negative 1/2, we don't want a positive 1/2, and we don't want a 2, then you are on the right track. So all you had to do was simply set each one of these denominators to 0 to figure out what your restrictions were. Now you should have written out everything, and the next step would be what you will write down when you have already canceled out everything. So once you cancel out everything, what did you get? Alright, so it looks like the 2x plus 1s will cancel out. You still have a 5 left over. So I'm going to put dot, 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 because you did the work there. You have a 5 left over. Then you have that 2x minus 1 and that x minus 2 left over, minus. And then what cancels out in the middle? That 2x minus 1 cancels out. And you should have had a 2x plus 1 left over and an x minus 2. And on the right side, you see that the x minus 2's cancel out. You have a 2 times 2x plus 1 times 2x minus 1. Alright, here what I'll do is write down the 5 and 4 here. So, and then we have also 4 again, and then we 4 again plus 2x. This is a difference of squares, so that middle will cancel out. Then we have 5 times 2x squared minus 5x plus 2, minus we have 2x squared minus 3x minus 2 equals 2 times 4x squared. That cancels, minus 1. Alright, I want you to see if you can finish this problem. Alright. So, hopefully you have already solved it. If not, pause and solve it and then start back up, okay? So we have 10x squared minus, now I'm distributing, by the way, minus 25x plus 10 minus 2x squared. So now it's a matter of changing all these signs because of that minus sign there. Plus 2 equals, we have, 8x squared there, 8x squared, that was a mistake. And then, look at that, the 8x squares cancel. Nice. Negative 22x plus 12 equals negative 2. And then we're going to subtract 12 from both sides. We have negative 22x equals negative 14 divided by negative 22. And what is that? So 2 goes into 14 7 times, and 2 goes into 22 11 times. So our answer is 7 over 11. Now level 3 is level 3 because you have to factor this denominator first. Alright, you have to factor this denominator first, and also in this level you will encounter a situation where you can't get rid of that x squared term, okay? And you have to, you work with what you have and follow the steps of solving equations when your degree is at least 2 or more. So first thing for this one, however, is we just need to factor the denominator first. Alright, so notice, which is kind of cool, is you shouldn't have to think too hard because it sometimes helps you out, right? The other denominators help you out with the factors. Alright, so we have and x plus 5 here. So what is the LCD? X plus 5 times x minus 4. So again, I want you to write it out and figure out what the restrictions are. And always, this is a tip, figure out the restrictions after you have factored the denominators. Okay, if the denominators are factorable, factor them first before determining the restrictions. So the restrictions for this problem are positive 4 and negative 5, or negative 5 first and positive 4. I probably should write it like that in numerical order. Set your factored denominators to 0 and solve for x. Now look over here. I want you to write it all out, but notice that the x minus 4s will cancel over here, right? You see that? And you will have that x times x plus 5 minus, and then in the middle you have that both x plus 5 and x minus 4 will cancel, and you have 12x equals, and on the right side the x plus 5s and the x plus 5s will cancel. You have x minus 1 times x minus 4. Then you have x squared, and then we have x squared minus 7x equals x squared minus 5x plus 4. And again, if we can get rid of these x squared, so subtract x squared from both sides, and you'll see that you get rid of them. And you have a negative 7. Now we can add 5x to both sides, and we get negative 2x equals 4. Divide by negative 2, x equals negative 2. So rewrite the problem with the factored denominators, and of course the factors for that difference of squares is x plus 3 times x minus 3. So what are the restrictions? The restrictions are negative 3 and positive 3. And our LCD is x plus 3 times x minus 3. So on the left side, when we distribute this, notice that the x minus 3's would cancel, and we're left with 2 times x plus 3 minus, when we distribute over here, the x plus 3's would cancel. We have 3 times x minus 3 left over equals, and on the right side, everything will cancel, and you have just 12 left. So that's 2x plus 6 minus 3x plus 9 equals 12. You could at this point subtract 15 from both sides, right? And that cancels that out. So you will have negative 3 here, and you could divide by negative 1 to get x equals 3. Well, the problem is that 3 is a restriction. Therefore, our solution to this problem is that it's no solution at all. No solution to this problem. So I know we have x equals 3 here, but what I want you to do is, when there's no solution, I want you to put a big fat X over it, because this is not the solution at all. It's no solution. And why is it no solution? Again, we're saying that x equals 3, but if x equals 3 here, then it would be 3 minus 3 in the denominator. And that is a problem. That is a big issue. It's called undefined. Our LCD is 2r, r plus 1. So let me write that down. So the LCD here. Now, to get the restrictions, you would have to set this denominator to 0, which is just 0, right? And also r plus 1 to 0, which is negative 1. So we don't want negative 1, and we don't want 0. So we're going to multiply, first of all, both sides by the LCD, which is 2r times r plus 1. So 2r times r plus 1 times the left side and also the right side. So let me write this one all the way out. I was skipping that step for the past 2 or 3 problems, but let's write it all out so you can see what actually cancels. What happens on the left here? The r's cancel, and they should. If you still have a denominator left, you know that you did not multiply by the correct LCD. You should get rid of all of these denominators. Then you have a 2 left, and an r plus 1 left. Plus, the r plus 1's cancel in the middle, and you just have a 2r left. And on the right side, the 2's cancel, but notice we have a 3, so I'm going to write that first. 3r left and an r plus 1 left. Now it's a matter of distributing and trying. We can't get rid of that r squared term. You see that? Alright. Now let's go ahead and put the two r's together. So that's 4r plus 2 equals 3r squared plus 3r. So when this situation happens, we have to follow those 4 steps that we have discussed in the past. These are the 4 steps. You get everything on one side, right? So I'm going to move everything to the right side. Since this is our leading coefficient here, is already positive and is already on the right side. So I'm going to move everything to the right side. So we will subtract 4r first. That cancels. We have 2 equals 3r squared minus 1r. And then let's move that 2 by subtracting it as well. So that 0 equals 3r squared minus r minus 2. Now, this is a trinomial, so you need to factor that. What I want you to do is attempt the AC method and provide the exact factors for 3r squared minus r minus 2. I'm not saying give me the numbers that will equal -6. I'm saying write out the entire binomial times binomial. Would it be plus in this one? It's going to probably be minus in this one because there's a minus here. And how do I check this? All I simply have to do is multiply this in my head to see if it's right. So that's 3r squared. That'll be that negative 3r that I want, plus 2r minus 2. Now what do you do from here? After you have factored, you do what? You set each factor to 0. So that's why we will set 3r plus 2 equals 0. And also r minus 1 equals 0. Subtract 2. 3r equals negative 2. Divide by 3. R equals negative 2/3. And r equals 1. So were those restrictions? No, our restrictions were -1 and 0. So actually, these are both of our solutions. Alright, this concludes the video on how to solve equations that contain rational expressions.